Today in Algebra 2, we are looking at section 2.3, and we're going to now look at the factored form of a quadratic function. And then within that, we're going to be able to find the zeros of a quadratic function because we have that factored form. So this is the third form we are looking at. So we're going to look at this warm-up, which will review the other two. So it says Corey wrote an equation in factored form. So we can see here that y equals x plus 8 times x minus 2 is what we're going to be talking about today to represent a quadratic function. Kimberly wrote the equation y equals x squared plus 6x minus 16. And remember, we've been talking about this already. This is standard form. And Joshua wrote the equation y equals x plus 3 squared minus 25. Remember, that is considered vertex form. So we actually have three different ways to write the same thing. Now the question is, do all three equations represent the same function? Now I said those are three different representations, but we don't know yet if they're the exact same. In order to do that, we could explain algebraically, or in order to show that, and you would just do the math we've talked about. To turn a vertex form into standard form, you would have to do the x plus 3 times x plus 3, and then subtract 25. When you distribute these to each other, you get x squared plus 6x plus 9. But then you have the minus 25, so it is x squared plus 6x minus 16. And you can see that is the same as the standard form. We could do the same thing with the factored form. We would do our distribution, and I would get x squared minus 2x plus 8x minus 16, which we can see is also x squared plus 6x minus 16. So we can, in fact, say that yes, all three are the same, and you can see that above. Now part B says, how else could you determine if all three equations represent the same function? Well, you could use your graphing calculator. If they are in fact the same, if I graph this, this, and this in the same window, I would get the same picture. And you can see at the right what that graph looks like. Last but not least, it says, what information can Corey's form help you find that is more difficult to find using Kimberly's or Joshua's? Now, we've talked about with vertex form and standard form how we can find the vertex. But one thing we haven't looked at, I guess we looked at a little bit graphically, but these are called the zeros of the function. So this is showing that there's a zero at 2 and negative 8. So if we take what Corey's form is, y equals x plus 8, and x minus 2. Isn't it true that where this graph crosses the x-axis, so the x-intercept, if I plug negative 8 in for the x, that would make this 0 because negative 8 plus 8 is 0. If I plug this x-intercept 2 in for my other factor, I would get 2 minus 2, which is 0. So that's actually why we call this those the zeros of the function, because those are the two things that would make the whole equation 0. And that's what we're going to learn a little bit more about today. Now again, the idea of this section is to be dealing with factored form. And in order to do that, we have to make sure we know how to factor. This is a skill that you have learned in the past, but many times students have a hard time with it, and they maybe don't remember. So we are going to take quite a bit of time here to do a bunch of different examples of how to factor. Now, you can teach factoring in so many different ways, but Pearson teaches this by making a table. So you might not have been taught this way, but this is going to be the way I'm going to introduce it because that's how Pearson teaches it in the younger courses. So in order to factor a quadratic, that's x squared plus 7x plus 12, notice that the a value equals 1. So on this first slide, we're going to look at three examples where a equals 1. And if that's the case, these are actually quicker and easier than when a starts to change. Okay, so if they're equal to 1, the table that Pearson uses is that you take whatever's here and you want to figure out all the pairs that multiply to get to 12, that's C value, and the numbers that add to get to 7. So once I have this table set up, now I think of all numbers that multiply to get to 12. So, oops, back to that. I have 1 times 12, 2 times 6, 3 times 4. And now I figure out what those numbers add up to. 13, 8, and 7. And now I find the pair that adds to 7, which is the 3 and the 4. And this is where if a is 1, so if there's no number there and a is 1, all you have to do is take these two numbers and put an x plus in front of them. So x plus 3 times x plus 4. This is factored form of x squared plus 7x plus 12. If you ever want to check your work or you don't trust it, you could just distribute it out. I get x squared plus 4x plus 3x plus 12, and we can see that is in fact equal to x squared plus 7x plus 12. Okay, I don't usually show that work, but on this one I wanted to show you basically what we did. Okay, let's do another example because the first example had all positives. The second one has a negative in it, so let's look at that. Again, I'm going to make my table. I'm going to think of things that multiply to get 8. Since a is 1, I can just do that. And things that add to get to a negative 6. Make sure if there's a minus, you bring it down as a negative. So I think of all pairs that multiply to 8, 1 and 8, 2 and 4, my only options. Now, as soon as you start having negatives, you want to think about your rules of positives and negatives. To multiply to get it to a positive number, I can either have 2 positives or 2 negatives. Those are my only options. So I'm multiplying to get a positive. So I either need both numbers to be positives or both negatives. And since I'm adding to get to a negative, that means it must be 2 negatives. Okay, so we want to think about our rules of negatives as we do that. I add up both pairs. I get negative 9, negative 6. We are looking for negative 6, which means these are my 2 numbers. I throw an x plus in front of them. Technically, I could do x plus negative 2, x plus negative 4. However, usually we would just write it as x minus 2, x minus 4. So as soon as I have negatives, I just put an x in front of the minus. And again, if you wanted to multiply it out, you could. All right, I want you to pause the video and try the third example on this slide by yourself, and then come back and check your work. So when you did this, you should have had multiply to 20, add to 9. If you built the whole table, you'd have 1 and 20, 2 and 10, 4 and 5, you get 21, 12, and 9. Adding to 9, you get 4 and 5, so x plus 4 times x plus 5. Now, the table, I need you to know, is just a tool. If you, as you started going through this, started to see patterns, and you can do it without the table, by all means do that. In fact, that's really good thinking. And if you can get to that point, you're in a really good spot. But the table is a tool to help you see it visually in case you need that. You also might be someone who uses the table, but you don't necessarily list everything out. You're watching as you go to see what you need. Okay, but again, note that it's this simple only when a is 1. A equals 1 in all these examples. As soon as a is not equal to 1, we have to add a couple of steps. So now we're going to look at a couple of examples of that. So here we can see that a is not equal to 1. For example, my first one, a is 2. I start with the same idea. I'm going to multiply to get to something. The difference is if you're multiplying with a not equal to 1, you actually have to take whatever a is. So 2 times negative 3. That is what you're putting in your table that you need to multiply to get to. Multiply to negative 6, the negative 5, adding to that, same. So the first thing that's different is rather than just taking the c value to multiply to, you have to multiply a times c. Now in theory, if a is 1, it's the same thing, but any number times 1 is just that number. Okay, so another example of negatives. Again, this time though, so I do 1 and 6, 2 and 3. But I'm multiplying to get to a negative. So we have to think about those properties of negative numbers. In order to multiply to get to a negative, I must have 1 positive and 1 negative in that number. As a result, I need to make one of these in each pair a negative. If I'm going to add to get to a negative number, that means that the bigger number is negative. So I like to skip steps. You could actually write out every possible combination, but I'm able to just kind of think it through like that. Okay, so when I do this, I see that 1 and negative 6 are my pairs. Here's the problem with factoring when a is not 1, though. I don't get to just say that x plus 1 times x minus 6 is my answer, because that would not give me a 2 for my a. In order to do this, I've found most simplified strategy for students is to then take this information and put it into a box. You take the first term, put it in the upper left-hand corner. Take your last term, that goes in the lower right-hand corner. And then you take these two numbers that you just found and put them with x's on the other diagonal. Okay, so I like to use this box to help me figure out how to find my factors, because once you have the box, then you are going to factor out the greatest common factor of every row and every column. What I mean by that is I'm going to look at 2x squared and 1x and figure out what they're both divisible by. 2 and 1 are just divisible by 1, but x squared and x have an x in common. Okay, go to this row, or column I should say. Negative 3x and negative 3 are both divisible by a negative 3. Now I go the two rows. 2x squared and a negative 6x, both are divisible by 2 and an x. And finally, 1x and negative 3 are both divisible just by 1. Now you can always double check. This is the area model. 2x times x is 2x squared. 2x times negative 3 is negative 6x. 1 times x is 1x, and 1 times negative 3 is negative 3. Make sure that your positives and negatives work out. Then once you have that, your factors are what's on the side. So 2x plus 1 times x minus 3. Okay, so now that we have that, let's do another example together. Again, I would do the 3 times 2, and I get 6, which means I need to multiply to get to 6, and this time add to negative 7. 1 times 6, 2 times 3. If I'm multiplying to a positive and adding to a negative, remember that's when everything has to be negative. So this time's negative 1 and negative 6 are my numbers. Maybe take a second, pause the video, see if you can fill in the box correctly, because that could be a new step. If you paused it, this is what you should have gotten. 3x squared in the upper left, 2 in the lower right, and then I take these two, negative 1 and put an x with it, negative 6 and put an x with it. Now I encourage you to pause the video again to see if you can factor out your greatest common factors. And now if you did that, again, I would look at the 3x squared, the negative 1x. They're both divisible by 1x. Negative 6x and 2 are for sure divisible by 2. But here's a trick for you. Anytime it's touching the box with a negative, you're actually going to have to factor a negative out. You could have pieced it together when you started to multiply, but the x terms on this box are always going to be positive. And so in order for me, because 3x times x is 3x squared, in order for me to get 3x times 2 to be a negative, one of them has to be negative. So it's going to be this one, because I would never make both these negative. Okay, same thing. I need x times something to be negative 1, so it'd be negative 1. Okay, and the negative 2 times negative 1 is positive 2. So you should add 3x and minus 1 here, which means it's the factor 3x minus 1. X minus 2 on top is x minus 2. Okay, last but not least, sometimes you'll have 2 terms instead of 3. Notice that it's the middle term missing. You are allowed to put in a 0x. As you go forward, you might see patterns that'll get you through that quicker. But again, here you're multiplying to negative 9, adding to 0, 1 and 9, 3 and 3. To multiply to a positive, or multiply to a negative, I would need to have a negative and 0. So I'm looking at these again because a is 1 in this case. So I get to just say it's x plus 3 times x minus 3. This is a special case. It's called the difference of perfect squares. So if you recognize that, it will always factor nicely, just like this, where it's opposites. But again, I wanted to show you that you are always allowed to throw a 0x in there. Okay, that's a long part of the video, and we haven't even gotten to the lesson yet. That's stuff you should have been able to do. So hopefully you feel good about your factoring, because this chapter assumes you know how to do it, this section. So now we're going to learn how to relate factors to zeros of a function. You can see that the graph shows the function defined by x squared plus 2x plus 8. So that's what this graph is. We want to know how the zeros of this function relate to the factors. So x squared plus 2x plus 8 can be represented as the product of two factors. So if we did what we just showed, it's x plus 4 times x minus 2. The x-intercepts are x equals negative 4 and x equals 2. And so this actually shows kind of what I talked about in the warm-up. If you substitute -4 into this problem for both x's, you get -4 plus 4 is 0. -4 times 2 is 6. And remember, 0 times anything is 0. If we take 2 and plug it into this equation, we get 2 plus 4 is 6. 2 minus 2 is 0. And again, anything times 0 is 0. So you can see it says that the factors x plus 4 and x minus 2 are related to the zeros x minus 4 and x equals 2, since each of the zeros makes one of the factors 0. Okay, so if you plug in an x-intercept or a 0, two-factored form, it makes the whole answer 0. So take a second and try this. It says the graph shows the function x squared minus 9x plus 20. Identify the zeros of the function, and how do the zeros relate to the factors? Your zeros should be x equals 4 and x equals 5. I want you to pause the video and factor it, and then see how they relate. So when you factored it, you should have gotten x minus 4 times x minus 5. And again, if we take 4 and plug it in, I would get 4 minus 4 times 4 minus 5, which is 0 times -1, which is 0. So this 0 makes the whole answer 0. If I take 5, I get 5 minus 4 times 5 minus 5, which is 1 times 0, which is also 0. So if I plug this in, I also get 0. So again, those zeros of the function turn the one factor into 0. Which leads us to this thing called the zero product property. And what that means is if you have any two things times each other, so A times B, it's going to equal 0 if A equals 0, B equals 0, or both. Okay, so if either one of those equals 0, the whole thing is going to be 0. And we're going to use this idea to solve a quadratic algebraically. So to solve a quadratic algebraically, you're going to get it into factored form, and then figure out what makes each factor 0. And that's the big takeaway from today's lesson. The problem is we couldn't get to that until we learned how to factor, or reviewed how to factor. So here we go. Big picture concept from section 2-3, day 1. Solve a quadratic equation by factoring. Okay, so we're going to look at x squared plus x equals 42. And you can see we're going to write down 4 steps to solving. The first step is to make sure you always set the equation equal to 0. Or get it equal to 0. And make yourself a note, you always want to keep a positive. When it comes to factoring, we want a positive a. So what I mean by that is I'm going to leave the x squared and x on the left side. So in order to get it equal to 0, I need to subtract 42 from both sides. So I have x squared plus x minus 42 equals 0. That's step 1. Step 2, you're going to factor. Now this won't come up today, but I want you to make a note that anytime you factor, you're going to look for the greatest common factor, or GCF, first. That'll come up when a is not 1. But again, our examples today won't have it, but tomorrow we'll start to look at that. So now I'm going to go through the steps of factoring. Again, a is 1 here, so I'm going to multiply to get to -42 and add to get to 1. My pairs to multiply for 42 are 1 and 42, 2 and 21, 3 and 14, and 6 and 7. To multiply to a negative, I need one positive, one negative, and since I'm adding to a positive, it was my smaller number, 41, 19, 11, and 1. So we can see we want these. So factored form is x minus 6 times x plus 7 equals 0. Okay, so again, knowing how to factor is the biggest basis of this. Because now that we have it in factored form, step 3 is we are going to use the zero product property, which means that if I can figure out what makes each of these factors equal to 0, that means if one of the factors is 0, the whole answer is 0. So one way to do that is to take each factor and set them equal to 0. And then finally you would solve for the x. So I'd add 6, x equals 6, subtract 7, x equals negative 7. So your final answers are x equals 6 or x equals negative 7. Both of those values, if I plug them back in, would make the whole equation 0. All right, so those are the 4 steps you go through. I want you to pause the video. Nope, we're going to do one more together. Just kidding. Next slide is try it on your own. Okay, so solve the quadratic by factoring. Again, that first step is to get it equal to 0. This is an example where technically the left side only has one piece, so you might want to try to move it, but we want to keep a positive. So in this case, I'm going to move both things from the right-hand side over. So I end up with 2x squared plus 9x minus 5 equals 0. So that's step 1, I got it equal to 0. Step 2 is to factor. Another quick review, multiply, these are different, so negative 10, add to 9. My options to get to 10 are 1 and 10, 2 and 5. To multiply to a negative and add to a positive, the smaller number must be negative. So these are my 2 values. However, remember, because a is not 1, I need the box. The first term, the 2x squared, goes in the upper left. The last term, the minus 5, goes in the lower right. And then these 2 values go on the diagonal with an x. Negative 10. Factor out the greatest common factor. And I believe, if I did this correctly, I get 2x minus 1 times x. Oh, this is a positive 10. So this is supposed to be a positive 5. Sorry. There we go. Everything else was right. X plus 5. Something did seem quite right as I was looking at it. Okay, so that's step 2. Step 3 is to set each factor equal to 0, because we need to figure out when each of those things equals 0. And step 4 is to solve for x. So you can see here, when a is not 1, you're going to have an extra step in the solving. X equals 1/2, or x equals negative 5. Okay, so if a isn't 1, you're going to end up with fractions as part of your zeros. Okay, now I want you to pause the video and try these 2 on your own. Again, really focusing on taking the time to factor. And hopefully this is what you got. I'll walk through again, but for the first one you should have got x equals 2 or x equals negative 10. Subtract 20 from both sides, which means we multiply to get to negative 20 and add to 8. Since a is 1, I got negative 2 and 10, so I just get to use x minus 2 times x plus 10. Once I have that, I set each factor equal to 0 and solve for x. Number 4 was a couple steps more tricky. We had to move 2 things to the left, so subtract 3x, subtract 2. I get 2x squared minus 3x minus 2 equals 0. And now in order to figure out the factoring, I multiply a times c, and I get multiply to negative 4, still add to negative 3, came up with 1 and negative 4. First term upper left, last term lower right, these 2 with x's on the diagonal. When I factored out the GCFs, I got 2x plus 1 and x minus 2 as my 2 factors. Took both those factors, set them equal to 0. My final answer was x equals negative 1/2 or x equals 2. Okay, so that was a lot of information. It was a little bit longer video. I apologize for that. I guess only a few minutes longer. But again, most of this video was on can you factor, which was a previous skill you should have already had. We do understand that that's one of the harder things to remember how to do in math. So hopefully this table idea helped you clean it up a little bit. If you have a different strategy for factoring that you were taught in your past and you know how to do it, you can factor using any method you are good at. I just wanted to be consistent and show some things that Pearson uses in the previous courses, but then also that you can connect to things that are maybe a little bit easier to work with. So go ahead and work on your Pearson practice for section 2-3, day 1.